So in this video, I'll be talking about how we code to get the adiabatic flame temperature, in which we talked about in the previous 3 videos. So the first thing I do, so I already had this set up. I just put in my anything I imported, so GitHub, pip install, import system, .map. I guess we don't need pandas, it's not used. We need tool tree data write transform because we need VSC, and we definitely are going to need range. Import, we need the chemical properties of certain elements, atoms, or molecules, and that's also given by CHE. We import JAX functions because we are going to use arrays and dot products and 64-bit. So, first thing I do, always set R equal to a constant, which is 8.314. And then next we need to get the chemical properties, which is P equals CHE dot, let's see, oxygen, nitrogen, carbon dioxide. Might have to check that later because I don't know if that's the correct formatting for it. Methanol and water. And let's see what it gives me. And it gives me an invalid. So, invalid syntax. Do something here. Yep, that's the problem. Props. And yeah, carbon dioxide wasn't the right syntax. And what else is wrong? It's not methanol, it's methane. So, yep, we got what we wanted. Then we do the modeling from here. So we do dot map C. So we get C dot CH4 is equal to 1, which is the amount of carbon we have at first for the carbon methane. We need the excess, so C dot O2 excess is equal to 0.2. We need to C dot feed temp is equal to 298.15, which is room temperature, and we're trying to find the C dot T, which is the flame, so we need a range function. So to initialize the gas, so 1,000, 800, 5,000. And this gives a gas temp within range of values. Let's see how it works. And of course, I had this backwards. C equals dot map. It gives me invalid syntax. Now, you need to define a model. So let's do another shift enter. So define model C. And for transform to, we got to make an R function. So R equals dot map. So spaces here. First thing we're going to need is the new value of CHC4. We need C, so R dot feed, what did I have it? O2. Okay. Equals C dot CH4 multiplied by the 1 plus C dot O2 that is 0. Is this because there's an excess of O2, and so we have to add a 1 so it's not a lower number, and we got methane, so it's 2 times, because for every methane there's twice the oxygen, so we get 2 times methane, or C dot CCH4 times the excess of oxygen plus 1. So that will get our initial feed of O2. Now we need our feed of N. So the feed of nitrogen, 79 by 21. I believe that's because of atmospheric conditions. There's atmosphere so around 78% nitrogen and 21% oxygen, 1% others. We're going to round it up to 79, and you multiply that by C dot O2 C dot 2 excess, and then next we can get the CO2 R dot CO2 is equal to, it's going to be the same as the methane, so CHC4, and yeah, that's the correct variable. So then we can get the R dash water, H2O, which will be the same as 2 times that C dot O2 excess, and then we get the R dash O2 product is equal to 2 times C dot CH4, since it's double moles, and this isn't making sense. Yeah, the oxygen and the water are going to have about the same. They're going to have the same, so it's not CO2 excess, it's C dot CH4. And I believe there is another mistake here somewhere. And the mistake is here where you got, I kept using excess for some reason. It is R dot feed O2 is what we need. And that gives us, that's all the values that we're going to need. But then we got to put it into an array function. So we use R dot, so we have the feed, which is the other temperature, and we have the flame, or the product. So R dot feed, and yeah, that's good. That's a good variable. It's equal to JMP dot array, and we do that, and what do we want first? We have oxygen, so you got R dot feed O2. You got nitrogen, so R dot N, 0 of carbon dioxide at first, and you got C dot CH4, and you got 0 water at first. Let's see if I have any syntax, define model. That's just because it's not defined yet. And then I do the same thing with the products. R.products equals jmp.array. And for this, will be R.2. It's not coming. Keep putting 0. O2 product. R.n. R.c2. What is well, since there's the methanol burned, so the 20% burned, so there should be 0 left. And R.h2o. We do that, and now we need the enthalpy of the product, so R.h feed, I'll feed first, is equal to P dot HIG, because P.HIG, that's ideal gas. So we get that, and NV moles, and T temperature. So you put R dot feed, that's going to give us the total moles, because here we create an array of final values. We do that for both. So it's R dot feed, comma, and it's asking for temperature now. And we have a temperature that's feed, so C dot feed temp. We do the same thing, so R dot H products equals P dot HIG for ideal gas, so R dot products and C dot T now, and it's going to find this T value. And this is enthalpy out, and this is enthalpy in. And when you do this minus that, you should get a function of 0, I believe. So now we'll return. We want a function of 0, so we do R dot H feed. Forgot that the brackets. R dot H feed minus R dot H products, and then we want it to show the intermediate steps. So let's put an R out there. Give it the space. Run it, and invalid syntax. Colon, Control C it. We want this here, and this here. So switch the places, Shift Enter. I believe now we could do VSC equals VSC. C dot C slash model, and then VSC solve dot solve. So let's run it off from here, there, and it's saying I have. Yeah, Jackson. Yeah, because I spelled array wrong. I wonder, where is that? Alright. So, why didn't it catch it right there? It's a real question. Gives us a bunch of values.